guys, welcome back. A couple housekeeping things before we get started. First of all, this video is sponsored by Digilent, and the hardware you're about to see was furnished to me by them, so thank you to Digilent. The second thing is that all thoughts and opinions that I will express in this video are my own and do not represent any company that I am currently or have previously been associated with. So with that out of the way, roll the intro. Alright, so today we are unboxing the brand new ADP2230 from Digilent. It's their new USB oscilloscope in their analog discovery series. Let's get this box open. Scissors. You know, it's kind of hard sometimes when I get these in the mail to wait until I'm on camera because I get excited. But let's pull, oh no, it's just packing slip. Feel like they ran out of packing material when they did. All right. So if you're watching my channel, a lot of you have probably already watched EEV Blog's video unboxing his 2230 and his subsequent teardown of it. And with that, I saw Dave himself had a lot of comments, along with a lot of the comments from his viewers was, where does the 2230 fit in the analog discovery lineup? So with the 2230, you've got one waveform generator output, two oscilloscope inputs, and then your digital I/O, which has a plethora of other functionalities in it, similar to the analog discovery 3. So the ADP2230 can be mainly powered off the USB port to the host PC where you're running waveforms. It does have the option to be powered by an external wall supply. That's really only needed if you need to use the upper range of like the programmable power supply, but for the most part, you're good with just running the USB port off of your host PC. Let's take a look at what else we have in this box. I don't know what to do with box parts when I'm doing this, so I just throw things. Got a nice beefy USB-C cable for our host PC, your MTE connector with your fly wires, and then the little labels for them, which I really appreciate this. Got some jumpers for your fly wire cables. This is all similar to what comes in the box for the AD3. You also have the option to include scope probes with your 2230. So I've got a couple of 10-to-1 probes. And then this is probably just the external power supply. Yep, external power supply with a couple adapters for different countries. So I'm going to clean this up a bit and then we'll move on. This is my favorite part. So as I previously mentioned, if you watched EEV Blog's video on Dave's teardown of his 2230, both him and his comment section pointed out that the 2230 does seem very, very similar to the AD3 or the Analog Discovery 3. So for those of you not familiar, across the entire Analog Discovery lineup or series, there is the Essentials lineup, which is the Analog Discovery 3, the Analog Discovery 2, and its predecessors. And then there's the Analog Discovery Pro lineup, which includes now the 2230, the 3250, its 4-channel variant, the 3450, and then also the 5250, which you'll see why this guy's on the bench here in a little bit. But in his teardown, not only did the specs seem very similar, but when he looked at the actual PCB within this guy compared to this one, they were remarkably similar. So I knew this was in the mail on its way when I saw his video. I hadn't actually received it yet, but I already knew that kind of highlighting like, why would you buy this over this guy was gonna need to be the focus of this video. If everything goes according to plan, this video should be live on launch day of the 2230, which is going to be February 29th of 2024. When I was doing the research and prep for this video, the 2230 wasn't on the website yet because Digilent actually has this great chart on their website. I'll link it below, but it just is a nice big spreadsheet essentially of comparing all of the Pro series and the Essentials series, but the 2230 wasn't on it yet. So for the sake of just rearranging the data for my brain to process and then also narrowing everything out to just look at the AD3 and the 2230, I made my own little Excel spreadsheet, which I will have up here as I'm talking through it, because I also saw a few comments asking, well, what's pro about the 2230? Why isn't the 2230 maybe just a refresh of the Analog Discovery 3? I decided to include the next closest variant in the Pro series to the 2230, which is the 3250. Saying lots of numbers, but I'll have it all on screen. So hopefully it makes sense. But that also will I kind of wanted to see, why is this in the Pro series? Why is this different from the Analog Discovery 3? Starting with price, the 2230 is about $400 more than the Analog Discovery 3, and then it's about $150 less than the 3250, and if you go up to the 3450, it's about a little over $500 less. Obviously, there's quite a big jump going from the Analog Discovery 3 to the 2230 in terms of price. However, not as much as previously going from the Analog Discovery 3 to the 3250. So why? What's the price difference? What are you gaining in that extra $400 going up to the 2230? Taking a look at the scope, first of all, you have the same number of channels across the board of all three, the same 125 megasamples per second across all three. However, the bandwidth is the first biggest difference. On the Analog Discovery 3, if you're just going through the Flywires or MTE connector, you only get about 9 megahertz of bandwidth. If you use the BNC adapter, that goes up to 30 megahertz of bandwidth. When you step up to the 2230, you get 50 megahertz of bandwidth. Then that's closer to the bandwidth that you're getting on the previous entry-level Pro series, the 3250, which gives you at least 55 megahertz of bandwidth. The next thing that's quite a bit different in the tech specs is the sample buffer size. This is probably the biggest thing that the 2230 offers over almost everything else. The 2230 has 120 megasample size buffer for each channel, whereas the Analog Discovery 3 only has a 32,000 sample buffer for each of its channels. And then the 3250 actually only has 128 megasample buffer total. So that's divvied up for all of its channels. So that's quite a big deal. If you watched Dave's teardown, one of the things that he mentioned as a difference between the PCB was that the Spartan 7 in the Analog Discovery 3 was actually a smaller variant, i.e. it had less logic cells in it compared to the Spartan 7 that is in the 2230. So that extra programmable logic is what is making that larger buffer size possible for the 2230. Moving on to the waveform generator, the con, I would say, of the 2230 in this category is that you only have one analog waveform output compared to the two that you get on both the 3250 and the Analog Discovery 3. Again, same sample rate, same resolution. They all have the same buffer size because you don't need the extra larger buffer on the output of that like you would need it on the scope. However, again, the advantage of the 2230 over the Analog Discovery 3 is you do have that improved bandwidth again. So you have 15 megahertz of bandwidth on the 2230 compared to the 9 megahertz of bandwidth if you're going through the MTE connector, or you get up to 12 megahertz of bandwidth if you go through that BNC adapter again. If you kind of look through the rest of the specs, both the bandwidth and the sample buffer size is kind of the common thing that goes through everything that makes the 2230 more advantageous over the Analog Discovery 3. The other thing that the 2230 actually stands out for, even amongst its other Pro Series lineup competitors, is the programmable power supply actually has a bit more capacity on it compared to both the Analog Discovery 3 and then the 3250. You can actually get 1 amp or 3 watt output. Caveat that being is you do need to use that external power supply to reach that upper end of the power levels. And then finally, kind of going through the rest of the chart, the last key differences that I noticed is the Analog Discovery 3 and the 2230 are both very similar in the fact that they only have their test connectors and then your host PC USB interface and the option for an external power supply. There's no other external connectivity options. Once you bump up to the 3250, 3450, 5250, you get a lot of extra connectivity options, including an Ethernet port. You have USB ports. That means you can use things like a Wi-Fi dongle. And then you also have the option for on the 32 and 3450s and then the 5250s, you can run them in Linux mode, so you're running a full-blown Linux image, and you can do some automated like test scripting. For that type of thing, you would have to have the script be on your host PC controlling waveforms versus actually on the measurements here. So if you really need a lot of that automation locally, you want to connect to it remotely, any of that stuff, that would be why you would go ahead and bump up to the 3250 or above. If you really need the portability, I think one of the biggest things about the Analog Discovery 3 that makes it appealing is it's super, super portable. I'll actually throw a picture up here. I was helping a friend out in an auto body shop. We were having some electrical issues on the CAN bus and a couple other places we were testing out. I literally just duct taped this to the inside wherever I needed it, and it was perfect for that. So if you're really looking for the portability, but you're nearing the end of the bandwidth that this can offer, or you need that bigger buffer size, that would be why you'd graduate to this guy. So he is a little bit beefier, but you still have that great portability, I mean, compared to the larger series. And then the other big thing that makes this portable is not needing the external wall power supply for everything, because the 3450, 3250, 5250, they can't operate at all without that external wall power supply. So they have to have the connection to your host PC and the wall power supply. These two guys, really you can predominantly use only on the USB bus off your PC. With all that being said, and my overall conclusion to answer the question of why would you buy the 2230 over an Analog Discovery 3, or where does this fit into the Analog Discovery series? I would say previously there was a fairly large gap going from the Analog Discovery Essential series to the Analog Discovery Pro series. I feel like the 2230 is kind of a nice middle of the road, perfectly in between those. I know the price does lean more towards the Pro side, only being $150 less than the previous entry-level Pro component versus being $400 more than the top level of the Essential series. But considering you get that larger FPGA for that bigger sample buffer size, and then you get, that's a pretty big jump on extra bandwidth that you get, which that would really be the thing that would choke you out of the Analog Discovery 3, especially in a Pro series, like a professional benchtop series setting. I would say maybe in a student or hobbyist setting, I really don't see a lot of people going outside of the bandwidth capabilities of the Analog Discovery 3. But definitely thinking from the perspective of my life working in a professional setting as an engineer, I would say I'd probably lean more towards the capabilities of needing the extra bandwidth on this guy. To demonstrate that, actually, I wanted to see what that relates to, because I think a lot of people, a lot of maybe like newer engineers or even hobbyists are asking, well, if you have the same sample rate on everything, according to Nyquist, that means you can sample up to half of that frequency rate. So half of 125 megasamples per second, that would be up to a 62.5 megahertz signal, which in that case is true. However, this is where bandwidth on an oscilloscope will sneak in and get you. You can imagine the bandwidth setting or the bandwidth spec of an oscilloscope is basically like a low-pass filter on that scope input. So once you go above that threshold, even though you can sample it at the appropriate rate, you're gonna start getting some attenuation. That attenuation comes from the fact that you're exiting the low-pass filter's pass band and you're getting into its transition band and ultimately its stop band. So if you're looking at, like for example, if we are using the Analog Discovery 3 with just the flywire connection or MTE connector, even though we've got the 125 megasample per second rate, anything above that 9 megahertz is gonna start getting attenuated, getting chopped off, starting to look weird. It's not gonna be its perfect sinusoid or its exact representation, because it's starting to go through, it's starting to get above the pass band of that low pass filter for the signal conditioning. So essentially that more so limits the scope measurement with this particular connector to 9 megahertz. If you use the BNC adapter, that does bump out of the 30 megahertz. However, the extra 20 megahertz that you get, at least going up to 50 megahertz bandwidth on the 2230, that's quite a bit extra. And another thing I remembered seeing in Dave's video is, even though he initially mentioned that the front end circuitry looked pretty much similar but on the PCB of the Analog Discovery 3 compared to the PCB of the 2230, he did mention it actually looked a bit longer. So it's that extra filtering probably is what that is. To demonstrate that, I thought it'd be good to actually get my laptop here, connect to both of these guys, and that is what the 5250 is out here for. You can tell I like Digilent and they've sent me quite a bit because it's on my bench all the time. But I'm going to use the waveform generator from the 5250. I'm gonna go ahead and just use the flying lead connectors because somewhere between New York and California, my BNC adapter disappeared. That's fun. I'm gonna output a signal and we're gonna take a look, and I wanna show you how that signal starts to attenuate once you get above the bandwidth specification, and then show you how on the 2230 you get that extra signal integrity with the extra bandwidth. Let me transition here and I'll be back. Okay, so I have my PC set up here, or my MacBook, and and I have my Windows virtual machine running because the only constraint that I don't really like about the 5250 is that it's only compatible with the Windows version of waveforms. I don't really understand that, but that's okay. I have a VM for everything because I always need some random different OS. So that's hooked up here. So I'm gonna have this out. I'm gonna go through a couple different sine wave outputs. I'm gonna start within the bandwidth of my Analog Discovery 3, which the maximum bandwidth of the scope right now with this connector is 9 megahertz. So I just have my BNC to test lead clip here, connected into some jumpers. So we're going to run this and then come to, this is waveforms on the Mac side connecting to my Analog Discovery 3. I set my time base to 200 nanoseconds per division for right now, since I'm starting with a 1 megahertz signal. And as you can see, we've got our full waveform, 1 megahertz, looks perfect, no clipping, great. So let's kind of work our way up. I'm going to change this to a 5 megahertz output. Coming back, everything looks great, no problem. So let's go up to 9 megahertz. Everything still looks good, but you can kind of see that the peaks of our sine wave are starting to look a little more triangle-y. We're getting to the end of our bandwidth filter here. So let's go ahead and bump this up to 15. And as you can see, our sine wave is even more distorted. We don't have our nice round curves. We've exceeded the bandwidth of the Analog Discovery 3 at this point. So yes, I'm still getting it. You've got that distortion from going over the filter bandwidth. But like I said, I hope this kind of gives you the visual of the difference between the sample rate of a scope and the scope's bandwidth. So let's switch over to the 2230 and run this again and see our nice, pretty rounded waveform. So I actually do already have this connected to my PC. As far as I'm aware right now with waveforms, you can only connect to one device at a time. So this is connected, the way I'm running both of them is this is connected to the Windows virtual machine. So I've got waveforms open in that. But I do need to, for the waveform instance running on the Mac side, I do need to come back to the hardware manager. Well, where are you? I am technically working before the official release. Maybe I was expecting the 2230 to show up, which the demo version does. Maybe I need to disconnect. Oh, there we go. Yep, I'm using a beta version. I'm not sure if that's the actual case, if you actually have to disconnect versus switch in the full-blown waveforms, or maybe that's just a bug of beta. I'm not sure, but disconnected Analog Discovery 3. One thing I did want to point out when you're connecting to any of the Analog Discovery series, you have some options for how to allocate the device's sample buffer memory. So in order to actually get that full 120 megasamples per channel on the 2230, that is the bottom selection here. You'll also notice that you can specify if you want the device memory instantiated in BRAM, which are instances instantiated in the programmable logic of the FPGA, or if you want the device sample buffer instantiated in the DDR of the device. Long story short, BRAM is a lot faster than DDR. However, there's only so much BRAM you can instantiate within an FPGA before the whole design is unable to meet timing and you introduce a lot of metastability into the data that you're pulling in and out of it. So for that reason, the option to have the full 120 megasamples per channel is only available to instantiate in DDR, and you cannot do that in BRAM because you wouldn't get good data out of it. There'd be too much metastability. For this particular demo, I don't need the full bandwidth. However, there's already a great write-up on Digilent's website of how to set up that deep buffer for the sampling. So I won't go over it here. I'll link that below, just because I feel like it's a lot easier to read versus watch. But I'm gonna select the default option, which does, it auto-distributes everything between BRAM and DDR. So let's go back to our scope, and that's still the waveform from the previous. So I still have this running at 15 megahertz. So let's run it now and see what it looks like on the 2230. One dumb thing a day. Not gonna see anything if I don't connect it. Hold on. Okay, now that I have the output of the waveform generator actually hooked up to the scope of the 2230, I had to take a minute. I realized I had a couple things going on. My beta waveforms is a little bit finicky right now. I realized my bandwidth limitation on the analog waveform generator here is 15 megahertz, so some of that clipping I saw here on the 2230 was coming out of this guy versus being measured in by this guy. However, since I'm working on the lower bandwidth 9 megahertz here, I have come back down that 15 megahertz here on the 2230 does look a little bit cleaner than that on the Analog Discovery 3. So overall, that just goes back to show what I was talking about, where yes, everything has the same sample rate, but that extra bit of bandwidth is ultimately what's gonna start getting you out in the field, particularly if you need to go above that bandwidth. I think the majority of users are perfectly happy with the lower bandwidth on the Analog Discovery 3, which, I mean, that's honestly, I say lower, but that's in relative terms. Like, I think this is great for use case, like most use cases, but I think there is a gap that was previously there between the Analog Discovery 3 and then the Analog Discovery Pro 32 or 3450. I think the 2230, like I said before, is a great cover for that gap. And if the Analog Discovery 3 is currently working for you right now and you're not hitting that buffer limit or the bandwidth limitation, I don't think you have any particular reason to upgrade. However, if you're in that more pro setting, but you still need all of that portability and you're hitting that upper bandwidth, I think the 2230 is a great solution rather than going all the way up to the 32 or 3450. That is my overall conclusion for this. I will say personally, I think I've got a couple things that this is gonna fill the bandwidth on. That project that I mentioned previously that I just used the Analog Discovery 3 for, I was troubleshooting some stuff on the CAN bus and I eventually found the issue, but that deeper buffer width definitely would have been helpful on the 2230. So I might revisit that with the 2230. But anyway, hopefully all of this information is helpful in picking which Analog Discovery device you need or helps you understand where this new addition fits in the lineup. Let me know if you have any further thoughts in the comments below. I'm also gonna link Dave's teardown video to this. I think it's a really great watch in and of itself. There's a lot of things I didn't go into super detail because I feel like he covered there. I have plenty more planned for this year. I'll eventually explain this new setup that I'm in, and yes, if you didn't catch it earlier, I have moved across the entire country. That's for another time. Bye. So while I was furiously tearing this apart to begin with, I didn't notice it, but when I came back for the cleanup, I noticed these are all little pouches, so don't get mad. I'm going to reuse all of these. I'm very excited. I have a plethora of bubble bags. Okay, bye.